The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Are there any questions over yesterday's assignment before we go on? All righty, then I'm going to switch screens here. Hopefully. And open up this one. All right, can everybody see the graphing screen now? Somebody? Anybody?
Yeah.
Thank you. All right, just wanted to make sure I got the right screen. Okay. So this is problem 17 from section 8.3. Oops. And let's see here what's going on. Part A says f of 2, negative 2. Part B is f of 0. Part C says the value of x for which f of x equals 4. And part D says the value of x for which f of x equals negative 2. So what we're going to be doing now is similar to what you did the last couple of days, only instead of having an actual function given, we're having a graph of a function given. So part A says f of negative 2. So what they're wanting us to do is find the corresponding y value or range value when x is negative 2. So it's like they're saying complete the following ordered pair. Given x is negative 2, find y. So looking at the graph, can you find a point on that graph that has an x value of negative 2? Well, here's x equals negative 2. So right there is a point with an x value of negative 2. What is the corresponding y value? Anybody? It's negative 4. Okay, so for this graph, f of negative 2 is negative 4. Any questions on that? All right. Next question. It says f of 0. Where on this graph is x equal to 0? Right there. What's the corresponding y value?
0.
0. So f of 0 equals 0. Okay with that? So all we're doing here is completing ordered pairs. Well, now part C, things change a little bit. It says the value of x for which f of x equals 4. So now what they want us to do is find x when f of x, which again is another name for y, is 4. So we want a point on the graph where the y value is 4. Oh, what's the x value right there?
2.
So x equals 2. All right. Then it says find the value of x for which f of x equals negative 2. Well, f of x equals negative 2 would be right there. So what's the corresponding X value?
One or -1.
-1. Yeah. So really, all these questions are doing is they're saying basically complete this table. Okay, but it's being asked in function notation. So f of -2 is -4, f of 0 is 0, find x when y is 4, find x when y is -2. Okay, we're doing the exact same thing as I just did in the table, getting points off the graph, but the questions are written in function language. Okay, any questions before we go on to the next page? All right. Here we have number 18, and we are to find, oh, this is the graph of the function s. We are to find s of -3, s of +3, the values of x for which s of x equals 0, and d, the values of x for which s of x equals 3. Now, slight difference here. Notice part C and part D, it asks for the values, not the value. So there's going to be more than one x value that has the same y value. That's okay. Two people can have the same birthday, still a function. So s of -3. Find the y value when x is -3. Oh, right here, x is -3. Right there. So what's the corresponding y value? Anybody? Well, it's 2. You see that okay? Well, I hope so. All right. S of 3. When x is 3, what's the y value that corresponds to that? 4. Then it says, find the values of x for which s of x is 0, or y equals 0. Where does y equal 0? Well, wouldn't that be right along the x-axis? So y is 0 when x is -1, when x is 1, and when x is 5. Those three x values all have a y value of 0. All right. Let's see here. The values of x for which s of x equals 3. Well, let's see. S of x equals 3 is right there. Oh, so x would be what? 2 and 4. X equals 2 and 4. Questions on that one? Okay, let's go on to the next one then. Problem number 20. It says find h of -3, h of 4, the values of x for which h of x equals 1, and the value of x for which h of x equals 0. Same questions, different graph. So h of negative 3, if x is negative 3, what's the corresponding y value? 4. H of 4, if x is 4, what's the corresponding y value? 3. The values of x for which h of x equals 1. Oops, right there and right there. So 0 and 2. X equals 0, 2. The value of x for which h of x equals 0. So what's the x value there? X equals 1. Are you getting this, folks? I'm not hearing anything. Just want some confirmation. Are you understanding this okay?
Yes.
All righty. Let's go on to the next example. Just wanted to make sure. 24, new question. Now we are to find the domain and the range. And we're going to use interval notation. All right, the domain is all the x values. Notice this arrow is going up. It's also going over. So this thing is going to keep going over and up. This thing is going to keep going over and up. So the domain would be all of the x values. Well, if this thing keeps going that way forever and that way forever, and it fills in between, the domain would be everything from negative infinity to positive infinity. That is all real numbers. The range, however, let's do the range in green. The range is the y values, okay? This thing keeps going up, this thing keeps going up, but it doesn't go down past 3. So the range would start at 3 and go to positive infinity. And it would include 3 because on the graph, it looks like this point is in fact included. Any questions there? Okay. Problem 26, same thing. We want the domain and the range, and we want them in interval notation. All right, now, this arrow is going down, but it's also going over slightly. So as it continues on, it's going to go that way forever. Same thing, it's going to go this way forever. Oops. So the domain, again, is going to be all real numbers. The range, however, goes all the way down here, but it only goes up to what? -1. So the range would go from negative infinity up to and including -1. Questions on that? All right. Once more, let's see, let's go back to black here. Domain and range. Okay. Now, this graph starts right here, but it continues on to the right. But it doesn't go forever to the left. This doesn't happen here, okay? Doesn't happen. So where does it start? It starts at x is 0 and continues on to positive infinity. The range, this thing's going down, and as it goes over, but it only goes up to 0. So the range would be from negative infinity up to and including 0. Question there. Okay. All right, here it says find a, let's see, this is the function g. Let's see, g of 1, g of negative 4, the value of, or values of x for which it would be g of x equals 4, and d, find the domain and range. So it kind of puts all the different questions all together in one problem. All right, so g of 1. When x is 1, what's y? 2. G of negative 4. When x is negative 4, what's y? Negative 4. Okay. The values of x for which g of x equals 4. All right there, which is what? Negative 2. And right there, which is positive 2. So x equals negative 2 and positive 2. All right. Let's see here. Domain, this thing is going down, but it's also going to the left. This is going down, but it's also going to the right, and it includes all these x values in between. So the domain would be from negative infinity to positive infinity. Let's see, does yellow show up? Yeah, I guess so. Range, this is going down, but it stops right here at 4. So it's going to be from negative infinity up to and including 4. Any questions there? Of course not. All right, let's take a look at problem number 72. The directions here say, determine whether each graph is the graph of a function. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. So in other words, one person has two different birthdays. Okay, we're going to use something that's called the vertical line test. Okay, now, if I go through and draw vertical lines through the graph, think of it this, whoops, that one didn't quite get straight there, sorry. Let's back that one up. Okay. Each of those vertical lines represents an x value. For instance, here we have x equals -1. Here we have x equals 2. Here we have x equals 4. But notice when x equals -1, there's two different y values. When x equals 2, there's two different y values. When x equals 4, there's two different y values. So this is not a function. And in fact, what I'm doing there, we call this the vertical line test. Drawing vertical lines through the graph. If it cuts through the graph, if a vertical line cuts through the graph more than once, it's not a function. Excuse me, because that means for a given x, there's more than one y value. For instance, when x is 2, y is, let's see, when x is 2, y is +2, and y is -2. So there are two ordered pairs where the same x goes to two different y's. So that shows that it's not a function. Okay. Next, how about this? Is this a function or not? Well, again, if we draw lines, vertical lines through it, oops, I forgot to click on the straight line. If we draw vertical lines, we see that it cuts through the graph more than once. So this is not a function. And an example would be the ordered pairs 3, -2, and 3, -6. In other words, these 2 points show that it is not a function. All right, I believe, yeah, that's all I've got. So, any questions? All right, so tonight's homework assignment is 8.3. I'm going to stop the recording.